Hey everybody, this is Bharat Muthuswamy.
And Amir Muqtadari. In this lab, we will become familiar with a breadboard, multimeter, and DC power supply. We will also simulate and build a simple resistive circuit to understand these instruments.
Note that we will not cover the instruments in detail. Please refer to the lab equipment videos on the CalESD channel. You can find the link from the LabVideo slides. Let's get started. The goal of this lab is to analyze, simulate, and realize the circuit below to find the value of I, that is the current flowing through resistor R2.
The theoretical analysis is simple enough. We can use current dividers. For simulation, we can use multisim. We don't have current sources in lab, do we?
No, we don't, Amir, but we do have DC power supplies that have current limits. So we can use that functionality, but first we need to devise a plan.
Let's use the current divider to find I. The current through R2 is given by the other resistance, divided by the total resistance times the input current. Hence, we get a value of 10 milliamps. Note that since R1 is equal to R2, this answer makes sense, since the input current I1 of 20 milliamps divides equally.
Good job, Amir. Now, let us use multisim to simulate the circuit and also understand the concept of current limit for the physical realization. Alright, so here I've started up multisim. Recall that a circuit consisted of a 20 milliamp current source in parallel with a 100 ohm resistor and parallel with another 100 ohm resistor. So that's what I'm going to do. There are many ways to make this schematic. I'm just going to follow one way. So let me see, I need to insert 20 milliamp current source. Let me go to power sources. Oops, that's not there. Signal current sources, DC current. That. Now go back to the basic, go to resistor, I'm going to insert a 1K resistor and then change the value. So 2 1Ks, R1, R2. Okay, and then rotate this, hit Control R. Okay, let's change the values. This was 20, and then go down to milliamps. This is 100 ohms. This is also 100 ohms. Connect all of them together, and remember that multisim uses SPICE as the back end analysis tool, and since that's a weird wire, okay, so that, and since SPICE uses nodal analysis, needs a reference node as ground, you need to add a ground node. So let's do that. The ground is under sources and power sources. There's the ground, so add this in. Okay, so on the right instrument toolbar here, I'm going to go down to the Agilent multimeter. This is the multimeter we use in the labs at the University of California, Berkeley's EECS department. So I'm going to do that. Alright, so I want to measure the current flowing through R2 from top to bottom. So here is the input current terminal. You can see the red eye over there. So what I'm going to do is I'm going to take this and go connect it there, and you can see the connection made. And then I'm going to go up here and make sure, there you go, it's connected correctly. Note that the meter is connected in series. That is, the current flows through the meter and back again through R2. Let me turn on the meter and then go shift, turn the DC current functionality on, and if everything's working as it is, as it's supposed to, I should see 10 milliamps. So let me hit the play button here, and voila, you see 10 milliamps. Okay, so now what I've done here is I've already created a project in multisim, or a file called lab current source, so that I have two circuits. This is the ideal circuit we would like to build. However, we don't have ideal current sources in lab. What we're going to do though is we're going to emulate the current limit functionality on the E3631A power supplies we have in lab. So here is the actual circuit we're going to build. We have a 20 volt voltage source in series with a 500 ohm resistance. Notice that this is not a 20 milliamp current source. What it is a 40 milliamp current source. And the actual current which is going to flow through the 100 ohms is given by the XMM2 multimeter configured as an ammeter, it's going to be approximately 18.2 milliamps. However, we're going to think about this 20 volt as your E3631A. That's exactly what it is, the DC power supply. We're going to current limit this guy to be 20 milliamps. So that means what is acting as the constant current source is the fact, or in other words, we're making use of the fact that the E3631A power supply has a constant current functionality. So we're going to set the limit on the power supply to be 20 milliamps. So as the current starts rising from the power supply, it does not go up to 40 milliamps. It goes up and stops at 20 mil. And Amir will actually show a demonstration of that, and that is the lab demo for this lab.
All right, so this is the lab simulation. So in front of us we have a breadboard. A breadboard is an easy way to set up circuits and prototype with them. So the way a breadboard works is it lets you make easy connections between different components. If you look at the side of the breadboard, for example up here, these rails are all connected vertically. So if you hold the breadboard like this, these are all connected vertically. So all of these are connected, and all of these are connected. Then in the middle of the breadboard, we've got this part, and you can see the letters A, B, C, D, E. This section of the breadboard, all the connections are made horizontally. So all of these pins are connected, and then the next row is connected horizontally, but between rows there's no connection. So this is the circuit that we have set up for our current divider. And we're going to show you how to set that up, but first let's look at the power supply and how to set up a power supply. So first of all, make sure your power supply is not connected to your circuit when you're changing the settings, or make sure the output is off. For the purpose of this lab, we're going to set the power supply to 20 volts, and we're currently on the voltage setting, but we want to limit our current to make a workaround for a current supply, because we don't have that in this lab. So if you go to the limits, you can see on the right that the limit is currently 1 amp, and we're going to change from voltage to current because we want to change the limit of our current, and we can use this dial to change it to what we need. So I'm going to move further down and get closer to our 20 milliamps there. So now we've got 20 volts coming out of the plus 25, and our limit is set to 20 milliamps. Now that's set up. Oh, it's 40, 20. All right, so I'm going to make sure my output is off, and then I can hook up components. So we've got the positive terminal, and then we have also our ground. And once that is set up and everything is connected back to the breadboard, then we can go ahead and turn on the power supply. So I'm going to do that by hitting the output on button, and now our power supply is working.
So one thing you want to notice is that notice that the power supply, let me turn the output back off, it's off. When you turn it back on, the voltage does not go up to 20 volts, because if the power supply has to output 20 volts, it's got to output more than 20 milliamps, but it's not possible. Notice, because of the current limit we set, notice how it says CC. So our power supply is actually now acting in constant current mode. So it's actually putting out 20 milliamps with a voltage of 11.15 volts across the output terminals. So let's confirm that you don't want to use the display output from the power supply to check your current. You need to measure it with a meter, and in this case what we have done is, let me zoom in. Oh, Amir forgot to mention that this burning here, it's not us. He just picked up breadboard from one of the cabinets. But anyway, circuit's broken here, and so this blue wire is going to one end of the ammeter, and then the other and the ammeter is coming back to R2. No, right there. Okay, so let's go to the ammeter, and as you can see, we are measuring 10 milliamps. So, and that's it for the lab demo. Okay, so we're done with the lab demo, and what we learned is basically how to use the E3631A, your triple output DC power supply, in constant current mode. That's it for this lab. Now, the next step is to actually go through the resistive circuits lab, and next time we will start with amplifiers or operational amplifiers in negative feedback. We'll be using chips or ICs to build interesting circuits. All right, see you then.